On December 4th, 1998, less than a month after the launch of the first module, Zarya, the second module, Unity, also known as Node 1, was carried into orbit as the primary cargo of the Space Shuttle Endeavour on STS-88.
10, 9, 8. We have a go for main engine start. We have main engine start. 4, 3, 2, 1. We have booster ignition and liftoff of the Space Shuttle Endeavour with the first American element of the International Space Station, uniting our efforts in space to achieve our common goals.
Roll program.
Houston's now controlling. Endeavour's rolling on a course heading northeast from the Kennedy Space Center toward a 240-mile-high rendezvous with the Zarya control module. Endeavour already traveling 575 miles per hour, altitude 3 miles, 1.5 miles downrange from the Kennedy Space Center. 3 engines on board now throttled down to 2/3 throttle to prepare the spacecraft to pass through the area of maximum aerodynamic pressure, also called max Q.
Throttle up.
Engines on Endeavour now back at full throttle.
Endeavour, you're go at throttle up.
Roger, go at throttle.
Altitude now 11 miles. Endeavour speed 1,500 miles per hour, 8 miles northeast of the Kennedy Space Center. 1.5 minutes since liftoff, Endeavour's already burned more than 2.25 million pounds of propellant, weighing less than half of what it did at launch. Altitude now 19 miles. Speed 2,400 miles per hour. Flight controller standing by for burnout and jettison of the twin solid rockets, coming up in about 10 seconds. Booster officer confirming a good separation of the twin solid rockets. Endeavour's speed now 3,200 miles per hour as it moves into its second stage, 3 main engines.
Endeavour, your performance is nominal. You are 2-engine Maroon.
Performance nominal, 2-engine Maroon.
STS-88 was the first space shuttle mission dedicated to the assembly of the International Space Station. Endeavour spent 2 days in a rendezvous orbit, during which it used the Canadarm to move Unity out of its cargo bay and attach the pressurized mating adapter to the shuttle's docking port.
The doors are actually opening at a faster speed here. They're shown at a faster speed than what we actually opened them at. It also gave us our first really nice view of Unity in the back of the payload bay.
On the second day of the flight, we went ahead and checked out the shuttle's robotic arm to make sure it was operating fully, and the shuttle's robotic arm worked just great. It flew identically to the way that our simulators fly. These are the snares closing. That's the manner in which we grappled Zarya, was through closing those snares onto the grapple fixture that was mounted to Zarya.
Made of aluminum and stainless steel, Unity would become part of the backbone of the ISS. Essential space station resources such as fluid, environmental control, life support, electrical, and data systems are routed through Unity to supply the work and living areas of the station. More than 50,000 mechanical items, 216 lines carrying fluids and gases, and 121 internal and external electrical cables using 6 miles of wire were installed in the Unity node. Prior to its launch aboard Endeavour, conical pressurized mating adapters, or PMAs, were attached to the aft and forward berthing mechanisms of Unity. Unity and the 2 mating adapters together weighed about 11,600 kilograms. The adapters allow the docking systems used by the Space Shuttle and by the Russian modules to attach to the node's hatches and berthing mechanisms. PMA-1 permanently attached Unity to Zarya, while PMA-2 provided a shuttle docking port and would be moved as the station expanded. Attached to the exterior of PMA-1 are computers which provide early command and control of Unity. Unity was also outfitted with early communication systems that allowed data, voice, and low data rate video to Mission Control Houston to supplement Russian communication systems during the early station assembly activities.
The rendezvous was absolutely fantastic to see Zarya, which means sunrise in Russian, out on the horizon as we closed in on it for our capture. What a beautiful sight. Rendezvous is a real team effort. You can see us working on the flight deck here as we approach Zarya from 600 feet underneath it. Everybody's taking pictures. There's Jim using the handheld laser to get an accurate distance from it along with our other tools.
On December 6th, the STS-88 crew again used the Canadarm to grab Zarya and mated the aft berthing port of Unity with the forward port of Zarya.
The Unity module extended about 40 feet out of the payload bay, and so the arm was almost fully extended as we brought Zarya up and over Unity into the install position. We actually couldn't see the mating surface where it was going to mate, so we had to use cameras alone. This is the elbow camera view. And again, we fired the thrusters to attain that capture sequence with the androgynous positioning mechanism.
On December 7th, STS-88 astronauts Jerry Ross and Jim Newman helped activate the Unity node during a 7-hour, 21-minute spacewalk.
We went right to work. We had one crew member that was normally working on the end of the arm and a foot restraint that we had attached there. And the other crew member normally did most of his work in a free float manner, holding on to the sides of the orbiter and space station as he did his work. Nancy operated the mechanical arm for the first 2 spacewalks, and Bob operated on the third one. The arm gives us a very good work platform. It gives us opportunity to have our feet anchored in a foot restraint, and therefore leaves both of our hands free to do the types of assembly work that we were doing.
They connected 40 connectors and cables running along the now 35-ton, 23-meter-long station. At 10:49 p.m. Eastern Standard Time, flight controllers in Houston saw Unity systems come on.
After the completion of the first spacewalk, we then activated the space station from inside and actually turned on the computers and electrical power to it, and what a great moment that was. After that, we boosted the space station to a higher altitude using the +X RCS jets on the orbiter. Each one of those jets gives about 800 pounds of thrust, and through a firing sequence that required a lot of analysis so we didn't break the space station. You can see it oscillating back and forth here after one of the firings. We boosted it approximately 8 nautical miles with 11 firings. A little oscillation in one of the solar arrays there. It was 2 minutes and 10 seconds between firings, and that all damped out before we did the next one.
On December 9th, Ross and Newman commenced a second 7-hour, 2-minute EVA to continue the installation of Unity. The 2 spacewalkers first installed 2 antennas on the outside of Unity, and then removed launch restraint pins on the 4 radial common berthing mechanisms. They installed covers on Unity's 2 data relay boxes to protect them from sunlight, and lastly, Newman freed a backup rendezvous system antenna on the Zarya. STS-88 Flight Day 8, December 10, 1998, was a historic day as the International Space Station was opened for the first time in orbit. At 2:54 p.m. Eastern Standard Time, Commander Bob Cabana and Russian cosmonaut Sergei Kerbal opened the hatch connecting the shuttle and Unity. They were the first humans to enter the International Space Station. The other members of the crew started unstowing gear and turning on the lights. At 4:12 p.m. Eastern Time, Cabana and Kerkalev opened the hatch into Zarya. Jerry Ross and Jim Newman assembled an S-band communication systems in Unity, and Kerkalev and Nancy Curry replaced a problematic battery discharging unit in Zarya.
We had to pinch ourselves every time we looked out the overhead window. It was just hard to believe that we were docked to a new International Space Station. The view of the aft and forward flight decks of Endeavour, kind of take you on a little tour as we transit through the mid-deck access hatch. Behind that door and curtain is the bathroom on the Space Shuttle. The mid-deck is where we do all our living and sleeping and eating. Here you can see Jim down on the mid-deck. He was in charge of transferring all the equipment to and from the space station, making sure that what went that was supposed to got there and what didn't stayed. Rick's bringing back some stuff that had been removed from the space station for shipment home to Houston. These large bags held all that equipment. You can see it was kind of a tight squeeze. We had a lot of stuff packaged all over. Again, transiting through the hatch into the tunnel that connects to the airlock. You can see a booster fan down there to help circulate air between all the modules so that we can scrub the CO2 and provide oxygen for everybody, as well as maintaining the proper temperature and humidity. Instead of going out through the aft hatch, we now go up through the upper hatch of the airlock into the space station. More of that ducting circulating the air. Into the pressurized mating adapter, and then down into Unity. Here's Jerry and Nancy reviewing procedures for the next work that they have to get started on. We were really busy for the 2 days that we were docked to the space station. Across Unity into pressurized mating adapter 1, and here comes Sergei floating by as he exits Zarya. Into the first compartment of Zarya. Again, you can see the ducting that we installed. And finally into the main compartment. Again, Zarya is not meant to be a living module. It's a working module and more or less a corridor between the other modules of the space station. A really fantastic facility.
The next day, astronauts Ross and Newman commenced a third 6-hour, 59-minute EVA to finish the installation of the Unity node to Zarya. The two stowed tools on the side of Unity to prepare for spacewalks on the next mission, STS-96, and Ross also freed another antenna on Zarya, similar to the one Newman freed on EVA-2. The spacewalkers also tested the redesigned safer jetpacks to be used in the event an astronaut became separated from the spacecraft during a spacewalk. After the EVA, pilot Rick Sturko depressurized the vestibule between Endeavour and PMA-2 to prepare for the undocking of the two spacecraft the following day. On December 13, 1998, Endeavour undocked with the ISS and performed a separation burn.
When we get to 2 feet, then I'll put in some out pulses, which will cause Endeavour to fly away from the International Space Station. As we backed away, we just had beautiful views of the space station that we couldn't really see as well when we were right docked with it, but it was just a beautiful sight against the background of the Earth there. Beginning the photo documentation, we flew around 1.5 times so that the station could be documented from all sides with different lighting. And those photos will be analyzed by the folks on the ground and used to train future crews as well.
What a fantastic view. What a sense of accomplishment to see an operating International Space Station on orbit.
That shows the empty payload bay. The mission wasn't by any means over yet. We still had work to do. And the next thing we had to do was deploy SAC-A, which was the first successfully launched Argentina-built satellite. And it has a number of small different experiments and new technologies which are being proven from Argentina. And we understand it's doing very well in accomplishing all of its mission objectives.
Two days later, at 9:46 p.m. Eastern Standard Time, Endeavour performed its deorbit burn, slowing the spacecraft to enter the Earth's atmosphere.
Now, as we re-enter the Earth's atmosphere, we have those special tiles that keep us from burning up. Otherwise, we'd be just a brief shooting star. But as it is, we do create a plasma behind us, which you can see here pulsing. And it's so bright that as it flashes and pulses, it flashes inside the cabin. And you can see out the window also that every once in a while there'll be a little shower of sparks. And I always sort of wonder what that was.
Pre-flare maneuver, coming down for a touchdown on runway 15 at the Kennedy Space Center. Our touchdown speed's about 195 knots.
At 10:49 p.m., Endeavour and crew landed on the Kennedy Space Center's runway 15. Endeavour wrapped up a 4.7 million mile mission and the first to the International Space Station. The next shuttle missions would continue to ready the station for long-term habitation.